This is going to be sections 5.9 through 5.10 for chemistry 1151. So this next couple of things we're going to talk about are going to be more related to your work in the lab. If you're taking the lab class, we're going to do a little bit of practice with it, but it's not going to be something that you're going to see a lot on exams and quizzes in this class. So don't put too much, you'll see it in homework a little bit, but you're not going to see questions that are like super difficult in the homework and in the quizzes. So keep that in mind as you move through this video. So first thing we're going to talk about is percent yields. So percent yield is basically how much did you make compared to how much you could have made. A theoretical yield, this is what we've been calculating. So a theoretical yield is the amount expected. So this is, if we do the math, we get our theoretical yield. So this is from the math. But if we actually go into the lab sometimes, then we might see that we made less than we actually had. So the actual yield is how much we actually make in the lab. So this will be from the lab or the experiment. Sometimes it's called the experimental yields. Yield is meaning the amount of products. So the formula for percent yield, which they should show you here, so percent yields is equal to your actual yield, so how much you actually make in the lab or in your experiment, over how much you could have made in a perfect situation, your theoretical yield, times 100 to make it a percent. So let's use that formula to look at this problem. So they tell me we calculated a theoretical yield of 23 grams. Sometimes you'll be doing that calculation using stoichiometry, but other times it'll be given to you in the question. What is the percent yield of only 15 grams of ethanol actually formed? So this is our actual yield. And this is our theoretical. We put actual over theoretical and we get a percent. So our reaction was 65% effective. The next topic, you're going to do this in your worksheet, and so we'll talk about it in class more on Monday, but you can go ahead and start working on the worksheet to refresh, or to start, not refresh, but to start thinking about the concept. The worksheet walks you through the concept here. A limiting reactant, sometimes called reagent, so you may see those two words used interchangeably, is a reactant that's completely used up in the reaction. It's also the reactant that produces the least amount of product. So it's true it's the reaction that's completely used up, but that's kind of hard to find mathematically. But if we compare how much product is made from each reactant, that's actually something we can do mathematically. It's not always the reactant that's given with a lesser amount. So it's not always the one that's given in a lesser amount. So you can't just say, oh, well, I have less of this thing. And that means it'll be my limiting reactant. So let's take a look at this sandwich here. So if I have 1, 2, 3, 4, 5, 6, 7, 8 slices of bread and 3 slices of turkey or whatever, and my sandwich is going to be 2 slices of bread and a turkey, I will have 2 slices of bread left over. So my turkey was limiting me to how many sandwiches I could make, and I have whole sandwich worth of bread left over. So if I looked at the bread only, the bread would give me 4 sandwiches. But if I look at the turkey only, the turkey would give me 3 sandwiches. So the bread gave me more sandwiches than the turkey. The turkey gave me the least amount of product. So we can figure out limiting reactant that way, where we can look at how much product do we make from each, and then which one gives us the least amount of product, or which one has leftovers. Or we can compare one reactant to the other. So we can say, how much O2 do we need to react with all of H2? And then we can figure out which one would be limiting. So in the picture here, we have 1, 2, 3, 4 moles of H2. How much O2 would we need to react with 4 H2s? So 4 H2s, so 2 H2s make 1 O2. So that would be, you can think about it like this. 2 H2s, that goes to 1 O2. And 2 more H2s, that goes to 1. So how many total O2s? We need 2. We have 1, 2, 3. Well, we have 3. So we have more O2 than we need to react with the H2. So the H2 would be limiting. I know that's kind of confusing. We're not going to talk about it too much in the form of comparing two reactants together, but that's kind of how we can think about it, right? So we can actually look at this picture here. I think it's probably easier. These two H's and this O, they kind of go together, right? Two H's and an O go together. Two H's and an O go together. Do you see how this one is excess? Which means our limiting LR would be the other one because it's the one that gets used up. That's how you can use pictures. You may be asked to use pictures on an exam to figure out limiting reactant though, because there's not the math we're going to show you in a second. And so we can use conversion factors for this. So this is just kind of using the picture, but we can also use conversion factors. You know that you have a mole to mole ratio, or you can use molecule to molecule. That's fine either way. Here's how they solved it. If we have 4 molecules of H2, we need 2 molecules of O2 because of this 2-to-1 ratio. We have 3 molecules of O2. So we have more than what we need, so the O2 is in excess. If we had less than what we need for the O2, we would call that the limiting reactant or limiting reagent. So it just kind of depends on what the outcome is. This is just kind of looking at what we talked about. This is something that you probably have done already, like in life. You've probably just like looked at like the amounts of something in a recipe, and you've done this math before, maybe in your head, but it's a little bit more present and direct here. All right, so let's think about it. How can we solve this using stoichiometry? So it's good practice for stoichiometry, so we're still going to do it, even though you won't be tested on a question like this, but you're still going to do it in practice, maybe in homework. If we have 10 grams of N2 and 10 grams of O2, which would the limiting reactant be? So a couple ways in which we can do this. We can figure out how much of the other reactant we need, or we can figure out how much product to make. Let's see what they do. So they figure out how much of the other reactant we need. So let's kind of follow that. I'll show you the other way in class. So we know we have 10 grams of N2, so let's say our 10 grams of N2. Let's figure out how many grams of O2 are needed. And then we can compare to 10 grams of O2 given. So don't use the mass of O2, just you're going to use it to compare. So go ahead and pause and see, can you go from grams of N2 to grams of O2 using what we've learned so far? First step would be to find the moles, and then to use a mole ratio. So you can go ahead and just look at that, pause if you need to. And then we use a mole ratio. This is how much O2 that we need from this much N2. And what they've done is, well, they did this a little bit backwards. I would have not done this. And then I would have said 0.357, or just kind of kept going, mole N2. And then we would have said it's 1-to-1 ratio. So 1 mole N2 is 1 mole O2. Sorry. And then we need to find the grams of O2 because they give us grams. This one, they did a bunch of extra work here. I don't know why. So let's just find the grams of the O2 that we need to react with our N2. So imagine that all of this, we're kind of connected to all of this right here. And we just did it in one long dimensional analysis. All right, divided by 20.2. 22. So we get 11.42 grams of O2 that we need to react with all of our N2. How much O2 do we have? We have 10 grams of O2. So we needed, this is talking about the moles that they did, but we're gonna divert from that really quick. So 11.42 grams of O2 needed, 10 grams of O2 given. We need more than we have. So O2 is your limiting reactant because we need more than we have. We don't have enough. So it was the one that will limit you. Then when you want to find your theoretical yield, you use the O2, the oxygen, to do that. So theoretical yield will be the amount of products made from O2, because O2 is our limiting reactant. The worksheet is going to take you through more of a product-based thinking about it, which is how I think is a little easier to think about it. So if you want to just compare the two reactants, kind of here's how you would do that. But in the worksheet, you're going to be comparing the products. So definitely look through the worksheet and let me know if you have questions, but I'll see you in class.